scientific computation for library, SciPy library in Python. So what is SciPy? SciPy is a scientific computation library that uses NumPy underneath. SciPy stands for Scientific Python. It provides more utility functions for optimization, states, and signal processing like NumPy. SciPy is open source, so we can use it freely. SciPy was created by NumPy creator Travis Olliphant. And why use SciPy? If SciPy uses NumPy, underneath, why can we not just use NumPy? SciPy has optimized and needed added functions that are frequently used in NumPy and data science. So which language in SciPy written in? So SciPy mainly written in Python, but few segments written in C language. So that is a SciPy. Now we'll talk next. What is the constant in SciPy? So once install SciPy in, so we can import a module SciPy. So after that we reach to constant in SciPy. As a SciPy is a more focus on scientific implementation. It provides many built-in scientific constant. These constant can be helpful when you are working with data science. So we just need to go Jupyter Anaconda editor, and now we'll move. Okay, so first we have to install SciPy. So just I'm doing pip install SciPy and execute the command window. So it will take time, within few seconds. If it is not installed, then it will install, otherwise requirement already satisfied. So already installed hai, so we no need to install it over here. Okay, so now we'll move to constant topic. Okay, so what is constant in SciPy? So regarding, I told you about the constant is a feature available in SciPy. So SciPy is more focused on scientific implementation. It provides many built-in scientific constant like that. So first we have to import a file like that in import the file first. So first we are importing a file. So how can we import? First from, okay, so SciPy import constant. Okay, so that is import of constant. Now we can see the print option of over here, and now constant dot pi. Okay, so we can see the value of pi. So now it will be the value of pi. That is a constant value. Okay, so again now I have just show you a different type of things. Already import my file, so I just print one more command in like that. So directory we want to say that, so a list of all unit under the constant module can be seen. So constant unit we can see the directory function by. Okay, so now you can see that that is a directory install in SciPy. So that is a list of unit available in like that. Just Avogadro, Boltzmann, BTU, BTU-IT, that is a SciPy directory and folder, so we can see that over here. Okay, so that is the part of SciPy library, and a lot of unit categories here: metric, binary, mass, angle, time, length, pressure, volume, and speed, temperature, energy, power, and force. So lot of things is over here. We can see that either I just show you just little bit. Suppose print command is here. So now constant dot iota. Okay, and just copy over here, and now, oh sorry, control Z, C, control V. Okay, so that is available features in this. Let me just exit first different types of features. ZETA, zeta, copy, then exa. Okay, then unit, this is major unit feature. Now we are using in hard disk, peta and tera, giga, terabyte, then gigabyte. Okay, these are the basic no feature. So we are having a different type of file: deca, kilo, hecta, meca. So I just press it over constant dot kilo. Then we can see that micro, yeah, nano, and then micro. Okay, so these are the basic features. We can see that of that type of length is available in like that. So you can see that that is a constant feature, a lot of feature we are having in that. Okay, and some binary feature also we are having like that in constant. So different types. Suppose I am just copy this feature, so that is a binary prefix. I just telling you regarding of this. Okay, binary fixes, we will talk about this. So that is first fixes like that. Suppose KIBI, kilobyte in binary, and now megabyte in binary, now gigabyte in binary, and terabyte in binary. Okay, so first two letter and next two letter of binary. So you can see that that is the value of binary. 1 kilobyte equals to 2 to the power 10 1024. So like that in this method. So that is a constant value. We can see that again we are seeing some special value in constant like that, a mass value. We can see that that means return the kg, gram, and return the type. So just copy it over here and just press it. Suppose gram, we want to see that that is a measurement unit. Okay, so now again we are just in grain. Again next we are taking pound. Again we are taking one more unit like that, ounce, OUNCE. Okay, ounce. And one more unit if we are taking about just like that atomic mass we can take is. So whatever unit you can see that like that display in this content. Okay, so every unit will be display like that. So that is a mass unit. Now we can see that angle unit also of this one. How can we see that angle unit? So that is simple, just copy and you just press its constant, DEGRE, degree. Next one is arc minimum. Next one is that arc sec. Okay, so now you can see that that is available degree. Now we'll talk about time also. In this features we are having constant time is that. So suppose I just copy it here and I just press it here, hour. Okay, then day, then week, then minute. Okay, then year, and we can see Julian year also. So JULIAN, Julian, YEAR. So now you can execute this file. So you can see that let me see that JULIAN. Okay, J should be capital. Okay, I think. So now you can see that Julian here, every measurement is here in this. We can see that. So now we'll talk about length measurement also. Okay, how can we measure length? Inch, foot, yard, mile. So it is simple, just you press it over here, inch, mile, millimeter, mil, point, yard. Oh, and next one is survey foot. I think foot. We'll talk about foot. Foot we are here. Okay, so you can see that that is a measurable units in length. A lot of unit is here. You can check your about the idle or either Jupyter notebook. Now we'll talk about pressure. So pressure is the unit for Pascal unit. Pascal unit. Okay. So suppose we are having again this file constant, and suppose I am just giving ATM. Okay, atomic mass, and now again is atmosphere. Okay, and now we can give a bar. Next one is that TORR. So you can see that are the measurable units of pressures. Now we can calculate area also of like that area if you want to calculate area of that constant. So that is simple, just you write down hectare, HECTARE, hectare. Now acre, and you can see that hectare and acre it will be show the default value. Now we can calculate volume also of this one. Volume, that means a liter, gallon, barrel. So suppose LITER, liter. Second one LITRE, liter. Gallon. And barrel. Okay, these are the volume level cylindrical form, so we can check it over. Now we can check speed also like that. So speed mainly return the specified unit in meter per second. So how can we check? At simple, just press it, print constant dot kmh, kilometer per hour. Then again mile per hour. Again we can just node types. Okay, so and we can calculate speed of sound also, this one, speed of sound, and now execute. So you can see that value it will be available. Now next we can see the temperature. Temperature, that means return the unit in Kelvin form. Temperature, we'll talk about temperature. So first one, constant, print constant dot 0 Celsius. Okay, and now print degree Fahrenheit. Degree and FARENHEIT. Okay, so let me set 0 Celsius. C should be capital, I think. Okay, and F should be capital of Fahrenheit. Now see that. Okay, constant has no attribute 0 Celsius. CELSIUS. Oh yes, not CS. Celsius, and let me just check. Celsius is there now. FAREFAHREN. So now you can see that temperature, Fahrenheit, and degree Celsius. Now energy also we can check about the energy. Okay, so that is simple. Just press it, constant dot EV. Okay, now electron volt. Electron volt, that is, and now you can see that okay. So now energy, and we'll talk about force also and power also. So next is the power function we are using, power. So how can we use power? That is constant dot iota. So we are just using HP, horsepower. Okay, and second one is another is horsepower. You can write HORAC, horse, and POWER. So you can see that that is the power. Both are the similar, but one is the short form and one is the full form. So now we'll talk about force in measurement. So force, that return the unit in Newton. So that is copy. So first constant dot dy and dyne unit, and second one dy and e, and next one is that can use a unit like that, lbf, and next one is that pound force, pound force, and then you can see that unit, measurable unit of that one. So that is a part of force. Okay, so now that is the constant unit of in SciPy. Lot of constant unit we are having. So now we'll talk about our next topic. We'll move to next in that case. So optimizer. So in SciPy optimizers, Optimizer, that means are a set of procedure defined in SciPy that either find the minimum value of function or the root of an equation. So optimizing function essential. All the algorithm in machine learning are nothing more than a complex equation that need to be minimized with the help of given data. So roots of an equation, NumPy is capable of finding root for a polynomials and a linear equation, but it cannot find roots for a non-linear equation like this one, x plus cos x. So for that, you can SciPy is optimized root function. This function take a two requirement argument. One is the representing equation, and second one is the uh, initial initial function return can be object with regarding this. So actual solution is given attribute of x return the object. So now we'll talk about in that manner optimizer. So optimizer, basically we discuss what is optimizer, how can you perform. So I'll just give one example like that from optimizer. Suppose from SCI SciPy that optimize import and root. Okay, first we have to import this header file, then from math import cos, then we design a function def keyword. So suppose equation is that my function. So eq is my variable, e is my parameter argument, and now a return of e plus cos of e. Okay, so that is my function defined. Now I just using my root function. So my root, I'm using variable. My root is the variable. Now a keyword we are using root, then eq, and our function called by 0 value. So now print, we can print functions. So my root dot e is the variable. Now we can execute of this code. Okay, so it is moving like that. Wait. Okay, so error is that what is the error is that cox. Okay, cox, sorry. Okay, cos, and now execute. So again my root dot e. So my root is the variable. Okay, so e is our equation variable. Okay, so I'll just change. Error is that attribute error e. Okay, so e dot cos plus e. Okay, so let me just give a space cos e. Okay, def equation e. Okay, and my root equation 0, and now print and now again error is giving e attribute error. So let me just change a variable. Maybe an e is a constant value, I think. Okay, and now now it is giving some, the above exception was the direct cause of following exceptions. So key error. Okay, so raise the attribute name from e. Okay, it's not calling. Where is the e? Okay, a. So that is a optimizer result dot get attribute. Self dot name is error. Okay, so from SciPy optimize root. Okay, and import math import cos equation of a, return a of a, and then root equation 0, and print my root of a. So I think it should not be error. Maybe some technical problem in my key error. Raise attribute is error. So name error is going on root. So find the. Okay, so yes, yes, we are doing mistake. Earlier we are just read about the distance. That is the x0 is the variable. Okay, so we are not using a. Yeah. So we have to using x. I think x will be work out over here. Either. Okay, so now. Yes, x is the variable, so we can use only x over here. Okay, so now we can call it this function again and again. So if you want to see this, print my root, and you can see the function, and that is a value of status and function. So you can see that like that. Okay, so now we'll talk about our next topic is that SciPy sparse data. So sparse data, SciPy sparse data is another thing, so we'll talk in next topic. Okay, till now, if you like my channel, please share and subscribe. Thank you, have a nice day. And if you like content, just please comment me. Okay, if you have any doubt, just ask me. Okay, thank you, have a nice day.